In June of this past year, something extraordinary happened. Something that reminded humanity just how small, fragile, and inexperienced we truly are when compared to the vast machinery of the cosmos. Our old companion Voyager 1, the silent metal traveler launched nearly half a century ago, encountered what scientists describe as a 90,000 degrees Fahrenheit wall of fire, a barrier of unimaginable heat and turbulence that no human, no spacecraft designed today, and no machine built with our present materials could ever hope to withstand. Yet this tiny probe from the 1970s, built with computing power weaker than a modern calculator, managed to press against it and send back signals across billions of kilometers, allowing us to witness phenomena that were once only theoretical dreams. When NASA launched Voyager 1 and Voyager 2 back in 1977, the mission was ambitious but modest compared to what we have achieved today. We wanted to explore the outer planets, observe Jupiter's storms, Saturn's rings, and maybe, if everything went perfectly, approach the very edge of the solar system. Back then, the idea of entering interstellar space seemed like something belonging to science fiction rather than scientific planning. But here we are in 2025, watching Voyager 1 not only cross that border, but push into unknown territories where no human-made machine has ever ventured. It is astonishing to consider how far the Voyager probes have traveled. For decades, they have been moving relentlessly forward, powered by a small nuclear generator and protected by technology far simpler than anything we have today. While the world changed around them, new nations rising and falling, the internet being born, humanity stepping into the age of artificial intelligence, Voyager 1 simply kept going, faithfully transmitting data until its signal grew weaker and weaker. And now, more than 22 billion kilometers from Earth, it has reached a region so remote, so delicate, and so extreme that physical laws behave differently. This region is known as the heliopause, a kind of invisible shell surrounding the solar system. Inside this shell lies the heliosphere, a massive bubble filled with charged particles constantly released by the sun. These particles form what we call the solar wind, a stream of energetic matter rushing outward in all directions. But eventually, these solar particles lose their energy, grow slower, and encounter a competing force, the interstellar wind that blows from other stars. At the exact point where these two forces collide, something incredible happens. Pressure from the sun finally gives up, and the dominance of the galaxy itself begins. That transition zone, the heliopause, is where Voyager 1 recently made its dramatic encounter. Understanding the heliopause is crucial for understanding the Voyager mission. Inside the heliosphere, the sun reigns supreme. Its magnetic fields, radiation, and charged particles shape everything. But beyond that region lies a territory ruled by the Milky Way's interstellar medium, a vast ocean of dust, plasma, and energetic particles ejected by ancient supernovas and other cosmic events occurring far beyond our solar system. When the solar wind and interstellar wind meet at the boundary, the result is turbulence of an intensity hard to comprehend. Here, particles collide at high energies, magnetic fields twist dramatically, and temperatures soar to tens of thousands of degrees. Scientists always suspected that something extraordinary happened at this boundary, but no spacecraft had reached it before. When Voyager 1 encountered this zone, the data revealed heat levels around 90,000 degrees Fahrenheit, temperatures that would melt, vaporize, or annihilate any conventional material known to humans. Yet because Voyager 1 isn't a living being, and because it isn't made to physically touch this plasma, it could detect these temperatures without being destroyed. It simply floated through the edges of this cosmic storm, measuring, recording, and transmitting its observations back home. The idea that a spacecraft launched almost 50 years ago could survive such conditions is itself remarkable. Voyager 1 wasn't designed with interstellar exploration in mind. It was constructed to make flybys of Jupiter and Saturn, take photographs, and gather data before slowly fading away. No one expected it to remain functional decades after completing its original mission. The fact that it continues to send information across unimaginable distances is a testament to the brilliance of NASA engineers from the 1970s and the durability of human ingenuity. Its instruments are old, fragile, and weakening. Communication is painfully slow. Signals require more than 22 hours to reach Earth and another 22 hours for instructions to return. But even with its aging systems and limited power, Voyager 1 has managed to remain our ambassador into the galactic ocean. Inside the heliopause, Voyager 1 is not just crossing a line. It is entering a fundamentally different environment. The space here is denser with high-energy particles. Radiation levels increase, magnetic fields behave unpredictably, and the relative calmness found inside the solar system disappears. The spacecraft is essentially navigating a frontier where our sun's authority fades and the influence of the galaxy takes over. This is the meeting point between the environment shaped by our star and the vast cosmic weather generated by billions of other stars scattered across the Milky Way. The collision of winds from different astrophysical origins produces shock waves, turbulence, and extreme temperatures. When scientists saw the readings of the plasma wave instrument on Voyager 1, they realized the spacecraft was detecting vibrations caused by electrically charged particles at incredibly high temperatures, particles that had been energized by the clash of solar and interstellar winds. This region is not a wall in the physical sense, but more of a transition zone full of energetic chaos. Imagine a river flowing into the ocean. At the place where the fresh water meets the salt water, there is a dynamic mixing zone. Currents shift, temperatures change, and turbulence appears. The heliopause works the same way, but on a scale beyond human imagination. The solar wind loses its speed, builds up pressure, and is forced to decelerate as it meets the interstellar wind. That pressure creates shock heating, leading to the extreme temperatures Voyager 1 measured. The spacecraft, while incapable of feeling heat like a human body, recorded the intensity of the plasma waves, allowing scientists to calculate the temperature. The data was astonishing. The environment that Voyager 1 traveled through was far more violent than models predicted. Scientists estimated turbulence and heating, but the actual readings exceeded expectations. Another surprising discovery is that the heliopause is not a simple, smooth boundary. Instead, it seems to be a wrinkled, shifting surface that expands and contracts depending on solar activity. During periods of high solar energy, the heliosphere swells, pushing the boundary outward. During quieter periods, it shrinks. Voyager 1 happened to cross during a moment of peculiar solar behavior, and this may explain some of the extreme conditions it encountered. The fact that the probe survived the crossing and remains functional is one of the great triumphs in the history of exploration. As Voyager 1 pushes farther into interstellar space, the data it collects becomes even more valuable. We are receiving information about the density of particles beyond the sun's influence, the behavior of magnetic fields in interstellar space, and the composition of material that has drifted across the galaxy for millions of years. Every signal from Voyager 1 is like a message in a bottle drifting across a cosmic ocean. Each measurement teaches us more about the galactic environment our solar system is floating through. And because Voyager 1 is the only functioning spacecraft in this region, every bit of its data is unique and irreplaceable. The story of Voyager 1's journey is not just about scientific discovery. It is about human curiosity and ambition. This little probe carries with it the golden record, a message created by Carl Sagan and the Voyager team that contains sounds and images representing the diversity of life on Earth. It includes greetings in dozens of languages, the music of different cultures, and photos of humans, animals, and landscapes. If any intelligent civilization ever finds Voyager 1 drifting in interstellar space, it will discover a snapshot of Earth from the 1970s, a time capsule of who we were long before we knew how far our creations would travel.